Okay, let's go over a couple more of these inverse functions and the derivatives of these inverse functions. So here we go. We got the derivative of this function here. Like we said before, if I tried to solve this for y, this would be quite difficult to do, right? So finding explicitly what f inverse is, right? To just be able to find what f inverse is, all right, this is going to be difficult, right? So to find that, that's hard to do, okay? So what we're going to do is kind of do it and find this derivative, evaluate it at 2, the inverse. Not so straightforward by finding the inverse function. We're going to use the fact that f inverse prime of x is equal to 1 over f prime of f inverse of x. Okay, so that's how we're going to do this one. We're going to maybe use a calculator or by inspection. Sometimes you can do these by inspection, but for the most part, these would be calculator type problems, or at the very least, it'd be some type of algebraic problem that you could solve for relatively easy. So for this one, we want to find f inverse prime of 2, f inverse, right, prime of 2, which is going to be equal to 1 over f prime of f inverse of 2. Okay, so now in doing this, we got to realize, well, we need to find f inverse of 2. Well, we don't have function f inverse, but we do have function f. And if this is the input for function f inverse, then that must mean this right here is the output of function f. So that means f inverse of 2 is going to be what? It's going to be whatever x will make that true. All right, so now we try to solve this, all right, for x. Now in this case, this is no different than trying to find the inverse, right? This is just as difficult to solve for x. But by inspection, we can even use the intermediate value theorem and check a number 0. If I plug in 0, I get -1. That's not enough. If I maybe jump up to 2, I get 2 cubed, 8, 16, plus 4, 20 minus 1 is 19. So that's too much. But now I went from a negative to a positive, which means there has to be a 0 somewhere between 0 and 2. It might make sense to try 1. 2 times 1, 2 plus 1, 3 minus 1 is 2. Oh, goody goody. X equals 2 works, right? So this, right, here, okay, this x is not this x being 2. This is the x for function f. This is the x for function f inverse. Okay, so what we really have here is that f inverse of 2, right? F inverse of 2 is 2, this 2, okay? So we have 1 over f prime of 2 then. And now this we can find easily enough because we know that function f right here, 2x cubed plus x squared minus 1, we can find that derivative, right? Easily enough. All right, so what is that derivative? Well, it's getting a little messy here, so let's jump down here. F prime of x is 6x squared plus 2x, right? In which case f prime of 2 is equal to 2 squared. 4 times 6, 24, plus 4 is 28. So then I get 1/28. Okay, so f inverse prime of 2 is 1/28. Okay, and you could, again, see the reciprocal nature, right? Just this one sometimes can get a little confusing because of the values being the same, that this 2 and this 2 just happen to be the same. In other words, the 0.22 is on both graphs. So there's that one. Let's jump over to number 5 here. Okay, so same thing. In order to find this, 1 over, right, this is going to be equal to 1 over f prime of f inverse of -3, right, which is equal to 1 over f prime of something. We got to find that something. All right, in this case, what is f inverse of -3? Well, this is one where if I plug -3 in here, that's not one I'm probably going to be able to find by inspection. So this one case, we'll go over to a calculator, right? We'll go over to look at a graph, right? So over here, here's our function, right? So what I want to do is find f inverse of -3, which means that's the output on function f right here. So right there, if we graph -3, we could see that, all right, f inverse of -3, because this is the output of function f. That must mean it's the input for function f inverse. So right there is 4, right? So f inverse of -3 is 4. Okay, so jumping back over here, 4. And now I'm almost there. I just have to find f prime of x. All right, here we have e to the power. E to the power is e to the power. Then times the derivative of 4 minus x, which is negative 1. And then the derivative of this, minus 1. And we can see here that if we plug in 4, f prime of 4, we get e to the 0, which is 1, negative 1 minus 1, negative 2. So over here, we get negative 1/2. Okay, so there is that one. Okay, number 5. All right, number 6, this becomes, at some point, becomes pretty straightforward. Hopefully you're getting the hang of it. All right, as we think about how to do these. All right, this one here, finding the derivative explicitly would be difficult. So we're going to rely on, f inverse prime of 1 is equal to 1 over f prime of f inverse of 1. In which case, we're going to have 1 over f prime of something. We got to find the something. How do we find the something? This is the input for f inverse, which means it's the output for some input here. So we know that this has to be 1. And whatever value gives me 1 is what f inverse of 1 is. Calculator problem, right? It's not solving this by hand. So if we go over there, now get rid of that. Here's my function. If I replace 1 as my output and see what input gives me that, in this case, I only have one input, 0.349. We'll talk about this more, but on the AP test, you have to go to at least 3 decimal places in your final answer, okay? And as you go along, in this case, using decimals, this is where it truncates it to, but really we should maintain full decimal accuracy here, right? So f prime of 0.349, now I know function f right here, f prime of x is going to be equal to 3x squared minus 8x plus 7. And then I have f prime of 0.349, right? F prime of 0.349. Let's do that here. Let's go this way. Let's call this f of x. And then 349. So we evaluate that and we get 4.573403, right? So that's what that would be. 4.573403. I lost track of what it was. Jeez. 4.573403. Okay. And then we could, we have the calculator, we can round that, and we again have to go to 3 decimal places in the end. Okay. So there's number 6. And now, right, as you look at this, number 7, hopefully at this point after these couple here, it's really starting to make sense, and you got the flow of what you got to do here. We want to know f inverse prime of 4. So in other words, we have to first, at some point, we're going to have to know what value of x will make this true, right? I got to find this. I know that f inverse prime of 4 is going to be equal to 1 over f prime of f inverse of 4. I'm going to find, here's where I'm going to find f inverse of 4. So we'll do that. And this is going to be a calculator problem. So here's our e to the x plus ln of x. We graph 4. There's e to the x ln of x plus ln of x. Here's y equals 4. We could see that 1.315 is what f inverse of 4 is. 1.315. So I know this is going to be 1 over f prime of 1.315. All right, that's this solution. That's what x is. Now I got to find the derivative of this function, f prime. F prime of x is going to be equal to e to the x plus 1 over x. So f prime of 1.315 would be equal to e to 1.315 plus 1 over 1.315. This value then would replace all this right there and you get 1 over that value. Plug in the calculator, you get your decimal 3 places at least, right? At least 3 decimals. You can go more, but you got to go at least 3. Okay? So there's those. And then the other type of kind of problem usually this type of thing shows up with is when you're given table of values, right? This kind of thing. That's not, again, it's not the only, but this kind of thing happens. So we read through, we got function f is differentiable, right? Keep in mind this in other contexts, that means the function's continuous, right? For all real numbers because it's differentiable. Here we got table of values that give selected values of f and x values and f prime and the values of those functions at those particular x values. We're told f inverse is the inverse of function f. Sometimes it might be stated as such, like g is equal to f inverse, and then you in place you might, or you'll say g is the inverse of f, and you might not see this inverse notation, but then you got to know this. So sometimes just write this down. So you're thinking that when you see this, that it's the inverse of function f. So in other words, it might say if g is the inverse of function f, right? So be careful of that. Pay attention to that. Find the equation of the tangent line to the graph of f inverse at x equals 4. Okay, so we're combining a couple of things here. We got to find the equation of a tangent line. And to find the equation of a tangent line, I need the slope and I need a point. Okay, all right, now of what? On the inverse function, right? Now I know the inverse function has an x value of 4, right? So I know the point here is, the point is 4 comma something. And here's one place where we can go arise. We look here and we see x equals 4. So then people will go here, see x equals 4, and then, either look at -8 or 5. Okay. You got to be careful because this x is not what we want, right? The other thing is, even if you did look here, neither one of these right here, that's function f, that's function f prime. Neither one of those are f inverse. So you shouldn't, even if you made the mistake and looked at this 4, you shouldn't put either one of those values down because neither one of these headers are f inverse. Okay. So we got to think is, well, how are we going to get the y coordinate, right? I don't know the functions. I just have some selected values. Well, because what? This is the input, right? Or more specifically, it's right here. This 4 is the input for function f inverse, which means it's the output for function f. And I go and look for an output of 4 for there's an output of 4 for function f, which means that what? Right there must be what? The other point, the y coordinate. That's what f inverse of 4 is, right? If this goes into function f inverse, then it must come out as what? -1, because now I know that if I plug in -1 to function f, I get out 4. Okay, the values flip-flop. So there's my point. And now the other thing I need is the slope. I need f inverse prime of 4. I need the slope at 4, -1. Well, that's going to be 1 over f prime of f inverse of 4, which would be equal to 1 over f prime of what? What's f inverse of 4? Well, if this is the point on f inverse, 4, -1, that means f inverse of 4 is -1. Well, what's f prime of -1? Now I can go up here. See, there's -1. F prime of -1 is -2. So this is going to be -1/2. And now I'm essentially done because my tangent line would be y minus -1. So y plus 1 equals m -1/2 times x minus x1 or 4. Okay, so that combines some different elements. The new stuff, the derivative of the inverse function. We got a table of values, and we also have the tangent line stuff. Okay, so that's the kind of thing with these inverse functions that we're going to be dealing with. Okay, we got to practice these. You got to review this, and it's at some point I think it starts to make sense. There's an element of really understanding when you see this x equals 4 that you can't look here and see x equals 4, and understanding that this 4 as an x becomes an output over here. This 4 as a y for function f, that kind of thing. So Make sure you look this over. If you're still not understanding something after you do the problems, homework problems and such, let me know. We get together. We'll go over it in some more detail. Make sure you get this, rather quickly. Okay, so let me know what you think.